Okay, welcome to week 2 of online chemistry with no end in sight apparently. So let's continue on with the gas laws. We've covered Boyle's law, which relates volume and pressure, Charles' law, which deals with volume and temperature, and then Guy-Luszak's law, which deals with pressure and temperature. So today we're going to put all three of those laws together and make the combined gas law. I'm sure you're all excited about that. So let's take a look here before I get back into the PowerPoint. Look at the three gas laws. Boyle's law, we have PV equals K. Is my handwriting better than last week? We have Charles' law, which was V over T equals K. And then Guy-Luszak's law, which was P over T equals K. Looking at them all together, you see that you always get pressure times volume and divided by temperature. So, in a sense, if you look at Boyle's law here, this constant includes the temperature, also the number of moles, but we'll deal with moles later. So, in a sense, temperature is part of this constant. If you pull the temperature out of it, you can bring it down underneath, and you get Charles' law. Of course, in Charles' law, they hold the pressure constant, so that pressure ends up being part of the constant over here instead. And again, you could go to Charles' law, pull the pressure out, bring it up over here, and get PV equals K. And the same for Guy-Luszak's law. So these three quantities are definitely related to each other, pressure, volume, and temperature. And each of these three guys found a different relationship by holding one of the three things constant and looking at how the other two change. If we put them all together, you'll notice we get PV over T equals constant. And that's just combining all the gas laws together, so we call it the combined gas law. Once again, we don't want the stupid constant in here, so we'll look at condition set 1, pressure 1, volume 1, temperature 1. And then we'll change to condition 2, pressure 2, volume 2, temperature 2, and they're going to equal the same K. And when you put it all together, we can go back to the PowerPoint and get P1 V1 over T1 equals P2 V2 over T2. Okay, that's the combined gas law, and it's really just combining Boyle, Charles, and Guy-Luszak all into one grand, glorious law. In this case, notice there's 6 variables. So I'm going to have to give you 5 of those. So for example, I might give you initial conditions of pressure, volume, and temperature. And then tell you, okay, well, the new pressure is this, the new temperature is that. Find this new volume over here. I can give you any of them, and I can make you find the pressure instead or find the temperature instead. You know, any unknown is fine. You know how to algebra as well as everyone else does. The combined gas law allows you to relate pressure, volume, and temperature all to each other. Now, again, the PowerPoint's big on rearranging the equation. So here they've taken it and they've taken T1 and multiplied it up top there. Again, you don't have to do that unless you like doing that. You can just go back to this form of the equation, plug in all the numbers you have, and then just rearrange and solve using basic algebra. That's the way I usually do it. So, they're just going through rearranging a bunch of stuff. Notice here they're showing in the special case where you don't change the temperature, in other words T1 equals T2, then notice the temperatures cancel out and you're left with just Boyle's law. So Boyle's law, in a sense, is a special case of this new combined law. And of course you could say the same about the other laws too. If P1 and P2 are the same, then they cancel out and you get Charles' law. So all three gas laws are really just simplified special cases of this more unified law that combines them all together. Back in the 1600s, 1700s, they weren't aware of that. They were discovering these things one at a time. Eventually, once they knew enough, they could combine them all together and realize that each one was a special case of the more unified law. And there's Boyle's law there. Similarly, you can do it with Charles and Gay-Lussac. We're going to, after this section, go into an even more, even larger, more expansive gas law, where we don't even need conditions 1 and conditions 2. But in order to do that, we're going to need to throw moles into there. I know Don's going to be happy about that. So let's look at some sample problems here. This is a very typical kind of problem you would do with the combined gas law. We have a volume of 30 liters. That's your V1. And then they give us a temperature and a pressure that goes with that volume. So that's T1 and P1. Notice again, your temperature has to be in kelvins. There's no option there. Your volume and your pressure could be in any units you like as long as you're consistent. Now, the question we're going to ask is, what would the new volume be at STP? Now, you have to remember back to a couple chapters ago, what is STP? Standard temperature is 0 Celsius, which is 273 kelvins. Standard pressure is, what unit do we use? So we use kilopascals, so 101 kilopascals. If you're using atmospheres, it's 1 atmosphere. Let me come over to my whiteboard here and write that. Standard temperature is 0 degrees Celsius, which equals 273 kelvins. That was a terrible 3. Depending what units you're using, that's your standard temperature. Of course, you're going to use kelvins in the math. Standard pressure is 101 kilopascals. If you're working in pascals, you can slide the decimal. You don't need me to do that. That equals 1 atmosphere. So if they give you units of atmospheres, standard pressure is 1 atmosphere. That also equals 760 millimeters of mercury, which on the worksheet sometimes we use that unit of pressure. By the way, all that means is that normal air, 1 atmosphere of air pressure, would push a column of mercury 760 millimeters up inside of a tube, of a hollow glass tube. So air pressure is pretty intense. It's just that we live with it all around us. We evolved in that pressure, so we're used to it. So if you need standard pressure, it's going to be one of these 3 numbers, depending on what unit you're working in. So let me go back to the PowerPoint. There it is. And continue this problem. Now you'll see, again, it's an ideal a combined gas law equation. They gave us our volume, temperature, pressure. We'll call that condition 1, V1, T1, P1. And then they ask us what's the new volume, V2, at STP. So here they show V1, T1, P1, we already said. T2 is standard temperature, which is 273. P2 is standard pressure, 101.3 kilopascals. They gave you a 4th significant digit here. If they had given this in atmospheres, that would have down there been 1 atmosphere. If they had given it in millimeters of mercury, this would be 760 millimeters of mercury. So now that we have all the things and we're looking for V2, you plug it in. So P1 goes there, V1 there, T1 there, P2 there, T2 there. There's your unknown V, solve for it. They're going to rearrange first again and then plug in, but whatever. You could plug your numbers in right there and rearrange afterwards. It's up to you. So there's all the numbers plugged in. Notice they were consistent in their units. They gave kilopascals. We didn't want to use atmospheres down there. That wouldn't work. It wouldn't cancel. You had to use kilopascals. Temperatures, well, they had to be in Kelvin no matter what. You're not allowed to use any other temperature there. Multiply the top, divide by the bottom. You know how to do this by now. We get V2 is 39.5 liters. Notice the pressure change and the temperature change. Sometimes it's hard to tell whether your volume should increase or decrease. You may have a situation where the pressure is trying to make it increase and the volume is trying to make it decrease, or vice versa, so you got to go through the math. Okay, so there they talk about, does it make sense? They ask you a really dumb question here. I'll let you deal with that yourself, but it's really straightforward. And that's it for section 2 of the chapter. In this section, we dragged it on almost a whole week, because we talked about a bunch of gas laws. Boyle's law, Charles' law, Guy-Luszak's law, and now finally today we're combining them all together in the combined gas law. Let me give you a worksheet on combined gas law to do for tonight. Sometime coming up soon, I'd like to do a quiz on this gas law stuff. I'm not sure if I want to do it right now or wait until we do section 4 yet. But you'll have a quiz coming up in your future at some point with this, and hopefully you played around with the online quiz to give me some feedback on how these things work. All right, that's good for today. I'll assign the worksheet, and we'll talk tomorrow.